Our next talk is Fingerprinting the Fingerprinters. It's a talk by Professor Zubair Shafiq. He's a computer science professor at the University of California, Davis. His research focuses on browser instrumentation and machine learning to improve ad blocking and anti-tracking. So I'm really looking forward to his research in this area. Give it up for Dr. Shafiq.
Thanks, Shetong, for the introduction. So just want to make sure you guys can see my slides. Okay, awesome. So today I will be presenting our research on machine learning powered anti-tracking. And our research focuses on a particular type of tracking, which is called fingerprinting. And many of you probably are already familiar with fingerprinting, but let me just start off with spending a couple of minutes to build some background so we're all on the same page. So third-party tracking or tracking in general can be broadly divided into two categories. So on one hand, we have stateful tracking, right, in which trackers store identifiers at the client side using cookies or other types of local storage. And on the other hand, we have stateless tracking, which is also called device or browser fingerprinting. Now, in fingerprinting, a remote server basically gathers distinguishing information about the browser or the device without needing to store any state at the client side. And this is what basically distinguishes fingerprinting from traditional cookies, that there is no need to store any state at the client side. Now, fingerprinting can happen in several different ways. At a high level, these different ways can be categorized into two types. The first one is what is called passive fingerprinting, where the server basically passively gathers distinguishing information at the server side. And this information is primarily gathered from information which is in HTTP headers. So this, for example, includes things like user agent, time zone, and any other flags which might be set in the HTTP request headers. And then we have active fingerprinting, where the fingerprinter actively tries to gather distinguishing information at the client side using different APIs supported in the web browser, and then exfiltrate that information to the server. And the typical set of APIs which are exploited for browser fingerprinting, they include things like fonts, canvas, WebGL, and so on and so forth. So you can actually figure out what your fingerprinting is, what your browser or device fingerprint is. So you can actually use one of these services, and you will basically see a complete breakdown of what are the different pieces of distinguishing information that your browser is leaking that might be exploited to construct a fingerprint. And basically what fingerprinters do is they basically piece together all of these distinguishing information together to construct a unique identifier for a user. Now, coming back to the difference between stateful and stateless tracking. Now, cookies basically store deterministic identifiers. So it's rather straightforward to understand how they work. But fingerprinting is actually a lot more tricky. So for a fingerprint to be a useful identifier, it needs to satisfy two main properties. So the first one, for example, is that it needs to be unique. So there has to be enough information, or what is also called entropy, in the information that can be used to generate a unique identifier to basically distinguish a user as compared to all other users on the web. And there is actually active research on whether browser fingerprinting is able to generate a unique fingerprint. But most of the research is pointing out that right now there is more that can be done, and fingerprinters over time have improved their ability to generate a unique identifier for users using browser fingerprinting. And the other property that also needs to be satisfied is the fingerprint has to be stable. So if it changes, then it should be linkable over time. And this is also quite tricky, and there is a lot of research which shows that browser fingerprinting is able to basically link this information which is exfiltrated from the browser, even if it is not very stable. Now, if you now think about this, clearly stateless tracking seems a lot more tricky than stateful tracking using cookies. But there are actually certain advantages over stateful from the perspective of the trackers. And the big one is that cookies are transparent and allow users to exercise control. For example, there are cookies in your browser. You can just directly go, you can see them and you can remove them. And it's unclear whether the same can be said for fingerprinting. It's unclear to users what their fingerprint is, and it's quite challenging or sometimes impossible for users to meaningfully change their fingerprint. And another reason, uh, which is putting stateless tracking more in the limelight, is basically this trend over the last few years where different browsers have been progressively restricting stateful tracking using third-party cookies. So Safari, for example, for many years has been putting different restrictions on third-party cookies. And in fact, they now block all third-party cookies, starting, I think, earlier this year. And Firefox also does list-based blocking of third-party cookies. So what does this basically mean? So this mean for like other mainstream browsers like Chrome. So Chrome actually also recently announced that in a couple of years, they're also going to get rid of third-party cookies from their browser. So there are, because of like all of these trends, there are actually genuine concerns that trackers will be transitioning from stateful tracking using cookies to stateless tracking using fingerprinting. And this will be bad for user privacy because browser fingerprinting-based tracking is more opaque and invasive as compared to traditional cookies. So there are good reasons to believe that fingerprinting will become much more widespread over time. So next, let me talk a little bit about like some of the issues with existing state-of-the-art countermeasures against browser fingerprinting. So cookies are rather straightforward to detect and block, but because they're right there in the browser. However, it is not that straightforward to detect and block fingerprinting, because you need to do sophisticated static or dynamic analysis of JavaScript, which has implemented the fingerprinting logic. And currently, unfortunately, this process is done manually, or like manual heuristics are curated. And the problem with doing this manually is that it simply does not scale to large number of fingerprinters, which are probably out there. And then if you do this manual work, you need to kind of like continuously redo it, basically just like the filter list related challenges that we have talked about today. So privacy-focused browsers such as Brave and Tor, they actually sidestep the problem of trying to detect browser fingerprinting, mostly because it's quite challenging. So what they mostly do is they try to, for example, try to normalize the APIs, where the goal is to break the uniqueness by making all of the users return the same fingerprint. And for this, they limit or spoof return values of some APIs like Canvas, which are known to be abused for fingerprinting, or they outright remove certain APIs. However, as you might imagine, this limits functionality and can cause site breakage, even when some sites are using those APIs for totally benign reasons. Another strategy which has been used in mainstream browsers is randomization, where the goal is to break the linkability by changing a user's fingerprint at every session or page load. But just like API normalization, this can also cause breakage. And there are also concerns that randomization is not a robust countermeasure because randomization can be reversed. So let me talk a little bit about what is the state of practice in ad and tracker blocking tools. So filter lists such as disconnect, they actually include a special category for fingerprinters. And what disconnect does is they again do like employ a manual review of reported fingerprinters. So they try to, for example, look at each reported fingerprinting script. But once you look at their site where they actually are transparent about how they go about determining whether a script is doing fingerprinting, you notice that they're basically looking for very telltale signs. They're looking for the obvious. For example, they look like whether this script is looking like some of the previously known fingerprinting scripts that they have detected. So if a fingerprinter is doing serious obfuscation, this manual review will not be very effective. And then this manual review is again like slow, just because it takes time to do this manual analysis rigorously. And there's a huge backlog of issues which are reported on disconnects Git repo. In academic research, there has been some research where people have proposed heuristics to automatically detect fingerprinting, but problem is like these heuristics are handcrafted and they're defined very narrowly to avoid false positives. So this is, for example, one of the most widely cited heuristic used to detect canvas fingerprinting. And as you can see, like this heuristic is making arbitrary choices on whether the canvas element width or height is larger than some arbitrary value. And the goal of this heuristic to do this is to avoid false positives. However, these kind of arbitrary choices make these heuristics quite brittle. So when fingerprinters actually change the way they operate, these heuristics break. So they need to be continuously tweaked and maintained to be effective. So to address some of these issues, we have been working on developing machine learning techniques to automatically detect browser fingerprinting scripts. So we proposed this system called FP Inspector. So FP Inspector uses machine learning to automatically analyze and detect fingerprinting scripts based on their behaviors. So it detects the existence of fingerprinting, but it's not trying to tell whether it's not trying to detect a particular fingerprinter. And for this detection, FP Inspector analyzes the JavaScript, and we instrument Firefox to do two types of analysis. One is static analysis, where we are basically looking at script content. Then we also do dynamic analysis, where we analyze script execution, such as the API calls made by the script. And once we have all of this information, we use this to train a machine learning model. And the nice thing about FP Inspector is now that we have this machine learning model, which hopefully can accurately detect fingerprinting scripts, it can be leveraged to implement very targeted mitigations. So for example, FP Inspector combines network level request blocking and API restrictions. So network level blocking, for example, is really ideal because it blocks both active and passive fingerprinting. But if this is done aggressively, especially on sites which are doing first-party fingerprinting, this can actually lead to site breakage. So in FP Inspector, we actually implement a hybrid of network blocking and API restriction, where network blocking is only implemented for third-party fingerprinting scripts. And then for first-party fingerprinting, we resort to API restrictions, where we block the APIs which are known to be abused for fingerprinting. And so it provides a nice compromise between the privacy protection and potential site breakage that can happen. So we evaluated FP Inspector rigorously on a large scale, and our results show that actually it is quite accurate. FP Inspector was able to detect many more fingerprinting scripts than were detected by previous heuristics or which are listed in filter lists. And we also found out that combining the static and dynamic analysis, it's very nice. These are two complementary techniques. For example, static analysis helps us address some of the coverage issues with dynamic analysis, and dynamic analysis actually is really helpful against fingerprinting scripts which are seriously obfuscated. And then our user study of FP Inspector further showed that our mitigations were actually much more friendly as compared to existing techniques. So we were able to actually reduce site breakage by a factor of 2 as compared to like blanket API restriction or like network request blocking because of this hybrid counter mitigation that we implemented. So this is good. So now we know FP Inspector works, and it can be used to implement mitigations which provide a nice trade-off between privacy protection and usability. We also then wanted to use FP Inspector and run it on a large scale to see like how much fingerprinting is happening, who is doing it, and why they are doing this. So first, some numbers. So we use FP Inspector to crawl top 100,000 sites. And what we found out was that fingerprinting is actually quite common. So the reference point here is a previous research from 4 to 5 years ago from Princeton's Web Transparency Project, where they showed that about 5% of top 1,000 sites and about like only 2% of top 100,000 sites were doing fingerprinting. And we found out that fingerprinting now in 2020 is much more common, especially on higher ranked sites, where more than a quarter of top 10K sites are doing fingerprinting and 10% of top 100,000 sites are doing fingerprinting. And it's not just that there is more fingerprinting. Fingerprinting is actually happening from many different domains. So in that previous research I just mentioned, they actually found that only about 500 domains were serving fingerprinting scripts on top 1 million sites. Whereas we found out that the ecosystem is much more diverse now. Fingerprinting scripts are being served on more than 2,000 domains on top 100,000 sites. So clearly there is a trend that fingerprinting is now increasing as compared to what was previously reported in research. And then we also did a breakdown of different types of sites where fingerprinting is happening, and we noticed that it is mostly happening on news sites that or other categories of sites which heavily rely on advertising for monetization. So this is something to be concerned about. And then we also looked at who is doing fingerprinting, and what we found out was top third-party domains which serve fingerprinting scripts are primarily anti-ad fraud services and CDNs. So we tried to do some analysis to try to figure out what is the intent behind fingerprinting. Are they trying to do fingerprinting in lieu of cookies? Or like there are some other reasons why they are trying to do this. It's quite hard to assess this intent. But when we were analyzing these fingerprinting scripts, we found out that about 1/5 of them were actually engaging in cookie syncing. So they were actually not just doing fingerprinting, they were also setting cookies and sharing cookies with other third parties. And we, in fact, found out that many of these fingerprinting services or fingerprinting domains, they were cookie syncing with many different advertising domains or domains which were classified as tracking by different filter lists, such as disconnect. So we think there is a reason to believe that fingerprinting is playing a perhaps increasing role in ad tech, and it might actually be used to support or aid targeting when cookies are not available. And right now we are interested in doing a longitudinal measurement to see how this is going to play out over time. But yeah, so our results show evidence that fingerprinting is increasing, it's becoming more sophisticated, and so on. So let me just conclude by talking about some of the impact of our research on not just the ad blocking and tracking community, but also where the web standardization and the browser community is going forward. So since we were able to detect many fingerprinting scripts or fingerprinters, which were previously not there in filter lists, so we have been actively engaging with filter list authors to incorporate these previously unknown fingerprinters in filter lists such as Easy, Privacy, and Disconnect. If you know Disconnect, you know that there is already like a special category for fingerprinters. And I was also happy to note that Easy Privacy now actually recently also has added a separate section for fingerprinting. So you can go look for the word fingerprinting, and they try to separately break down sites where fingerprinting is happening. And there are very aggressive rules to block that kind of fingerprinting. So that's really good to know that our research was transitioned and has been picked up by some filter list authors to improve the quality of filter lists and provide protection for every ad blocking, tracker blocking user. And then there is also this, so our research also points out that these fingerprinters, they are exploiting the variety of different web APIs for fingerprinting. And there is right now a palpable tension between the desire to actually implement and roll out new APIs to support cool new functionality and their potential privacy implications with respect to fingerprinting. So I actually engaged with W3C Privacy Interest Group, and this tension happens all the time. And if you have tried to keep track of different API support by different browsers, you probably have noticed that browsers like Firefox and Chrome, they're increasingly diverging on the on different web APIs that they support. And we believe the problem is going to get worse because as these new APIs are implemented, we find out that they're then actively being abused for fingerprinting. So for example, in our research, we found out that many fingerprinting scripts were using different APIs, which are used, for example, for permissions to fingerprint functionality of a device or a browser. For example, does the device have um, geolocation permissions? Or what is the layout of the keyboard of the device or of the keyboard connected to the browser or the device? Then we also saw that some of these fingerprinters were doing algorithmic fingerprinting, where they were exploiting the timing information or trying to figure out what was the animation frame rate supported by the browser, or audio information and mobile sensors and so on. So there are all these like new APIs which are out there, and now fingerprinters are actually actively using those APIs. So it's going to be an interesting challenge, I think, moving forward to see how we can basically balance the cool stuff that these APIs support and then their abuse by fingerprinting scripts. And finally, I also want to very briefly talk a little bit about the privacy budget proposal API, which is part of the Chromium's privacy sandbox proposal, where I think our research can also really help. Right now, FP Inspector is only trying to detect whether a script is doing fingerprinting or not. But as part of this privacy budget proposal, they're actually trying to see if they can, in the browser, quantify in real time, perhaps, how much information or entropy is leaked by a fingerprinting scripts, and whether that can actually be used to then implement countermeasures. And we are right now thinking about how we can actually advance or improve FP Inspector to incorporate that in our mitigation as well. I will conclude with a shout out to my co-author. So this work was primarily led by Umar, who is a PhD student, and he also spent some time at Mozilla. So our collaborator, Steve from Mozilla, also really helped with this research. This work was recently accepted after peer review. And so you can actually go read the full paper for a lot more interesting details. And if you're interested in trying FP Inspector out, or if you're interested in some of the data, all that information is available in this GitHub repo. And feel free to reach out if you have any additional questions about our research. And I will just stop by doing a shameless plug about this new academic research center that we have just started. So I'm co-leading this new NSF center on protecting personal data flow on the internet. So this is a $10 million collaborative research center funded by National Science Foundation in the US. And we also have collaborators from EU. And we are trying to basically improve privacy enhancing tools. And one of our thrusts focuses on anti-tracking and ad blocking. So please join us if you are looking, for example, for grad school or postdoc. We would love to hear from you. And we are also actively looking to collaborate with industry stakeholders. So if you're interested in knowing more about this research, or basically giving some input, some of the research directions we choose to pursue, we would love to hear and engage with you. And with that, I will stop, and I'm happy to take any questions.
Amazing. And also scary, the kind of information that you shared. It is quite alarming, and I think once again, we as the whole community need to really think about where all of this is heading and how we can do our part to stop it. Having said that, let's go into some questions. The first one is from Torsten Kleins. In the TCF 2.0 cookie dialogues, there is a category for fingerprinting. Can you find these, and are those declarations correct?
So we have not looked at TCF 2.0 cookie dialogues, but yeah, I like this suggestion. We can definitely use FP Inspector to actually validate whether the declarations are correct. So yeah, we have not done this, but we can definitely try. Thanks for the suggestion.
The next one is from Ben Standard. Do you have any numbers on the prevalence of fingerprinting, or what device characteristics are most commonly used in fingerprinting?
Yeah, I believe I shared some numbers on prevalence of fingerprinting. For example, like more than 30% of top 1,000 sites are doing fingerprinting, and about more than a quarter of top 1,000 sites. Um, I did not like report numbers on like which APIs or which basically characteristics are most commonly used. We have like those numbers in the paper, but at a high level, basically things like canvas and fonts, like the traditional well-known fingerprinting vectors, they're most commonly used for fingerprinting. But then there is this long tail of like other features, which are also used for fingerprinting. And our paper basically has a detailed breakdown of different APIs and methods used for fingerprinting. So I would definitely refer you to read the paper on that.
Okay, the next one from David Oakley. Aside from the Brave browser, are there any other ad blockers or browsers that prevent fingerprinting?
Yeah, every basically browser, privacy-focused browser, or like privacy-focused ad or tracker blocking extensions, directly or indirectly, actually do have some fingerprinting protections implemented. So, for example, Firefox uses disconnect list, which specifically blocks fingerprinting. So there are protections against fingerprinting in Firefox. And if you're using one of these ad blocking or tracker blocking extensions, which is using easy privacy, they also have rules to block fingerprinters. So again, the range of protection and effectiveness of protection ranges like across different browsers. But the good news is like most privacy-focused browsers have some sort of like fingerprinting protection already implemented, or their plans to roll out fingerprinting protection in near future.
Yeah. How much data is actually necessary to create a unique fingerprint, particularly when combined with an IP address?
So that's a great question. So this is actually a hot topic of research right now. So from a theoretical perspective, if you want to, for example, distinguish any user on planet Earth, theoretically you need 33 bits of entropy. So you need to, that's basically, you want to distinguish one person out of a population of roughly about 8 billion. Now, research has shown that some well-known fingerprinting APIs, information that you can glean from them, is not enough to give you 33 bits. But then, as you say, like when you combine this with some other information, like IP address, there is research which shows that there is clearly enough to uniquely identify, to develop a unique identifier for a user based on that fingerprint. There is actually also some research which shows that trackers don't actually need to have a unique identifier for you, in the sense that they need to distinguish you from all other web users out there. So even having an identifier which potentially has some collisions, for example, if it is based on only, let's say, 10 bits of entropy, can actually be enough to identify you in a smaller population, especially when you slice data based on location or publisher or some other factors that also come into play.
Great. These are all the questions for now. If you have more questions, then of course you can ask on the Slack. And thanks, Zubair, for all this. This is amazing information, amazing research, and I hope that we get to see you next time as well with some more amazing research.
Definitely. Thanks.
All right. Bye.